Alright guys, welcome back. Today we're going to talk about proving congruence. So we'll be proving formally from now on for many days, including congruence and similarity. So let's start with congruence. So basically, in order for you to prove two triangles being congruent, you need to have three sides equal and three angles equal. So that you actually need to make sure you have six things being equal in order for you to have congruence. But then we realized that we actually have shortcuts, what we call the big five. Well, I just named it by myself. Okay, you have SSS, SAS, AAS, ASA, or RHS. So that's what we talked about yesterday. If you could actually have, these three different kinds of pieces of information, you could actually prove congruence without actually having to check through all six pieces of information. It sounds like a good deal. But what is even more powerful is that you can actually go backward. So if you know that you have congruence already, you can actually go back here to claim that all the three corresponding sides and all the three corresponding angles are all the same, including those ones that you don't know. So that sounds like a good deal, eh? So before moving on to the examples, I want to go over the following terminologies with you. I hope this is more like a review for all of us, but let's check it through together. Give yourself a few seconds. You could pause the video if you want, and whenever you're ready, we'll go on together. Okay, so now the first thing is we see a diagram over here with two parallel lines over here, and we are asking where are the complementary angles. So here's the thing that people always kind of mess it up a little bit. What is complementary? What is supplementary? Which one is 90 degrees? Which one is 180 degrees? According to Mr. K, he has a method over here. He says if you think about complementary angles as the word complement, okay, although not exactly the same word over here, he says if you give compliment to people, you're actually giving a thumbs up like this. Okay, so that means you're actually forming a 90-degree angle. That sounds very Mr. K over here. But yeah, it could be a good way for people to memorize. So that means actually when we're talking about complementary angles, we are actually talking about adding up to 90 degrees over here. Okay, and then when we're talking about supplementary angles, we're actually talking about adding up to 180 degrees. Okay, there's actually another way that I found on the internet that makes a pretty good sense as well. If you think about complementary as corner, okay, also started with C, that means we're talking about a 90-degree corner. Okay, if you think about supplementary as straight line, okay, straight line, which also starts with S, then you can kind of relate that as a straight line which has a 180-degree angle as well. Okay, so either way, these are all good ways of memorizing, so you can use whichever one as long as you don't mess it up. So which ones are complementary angles? Obviously, for the first one, you will see that A and B are complementary angles. Okay, for supplementary angles, we actually have a lot. As long as they add up to 180 degrees, we are supplementary angles. You could have C and D, C and E, E and F. So basically all these pairs over here, they are all supplementary to each other pairwise over here. But not only that, actually, as long as you can add up to 180 degrees, we are also a supplementary angle over here. So for example, this B and C over here, remember these two angles will actually add up to 180 degrees because of the parallel lines over here. So we will put B and C. Okay, and last thing, just because C and F are exactly the same thing over here, so that means if B is supplementary with C, that means B is also supplementary with F as well. Okay, so that's a long list over here. Moving on to opposite angles. Opposite angles, it's quite intuitive. Basically, just the ones right across each other. And we have E and D. Moving on to corresponding angles. We have, in this case, I think just one pair. Right, we have B and D. We're really talking about this case over here, that you have alternate angles. We're talking about this zigzag situation over here. Okay, so in this case, we have B and E. And that's pretty much it. Take a look at it. So now this is the first time that we see a proof kind of question over here. You can see that the keywords are explain, prove, show. Okay, if you see these kind of words over here, it doesn't really matter which one you see. We are actually all talking about proof in this case. And we actually have a certain structure that we need to follow in terms of proving at this stage over here. So let's get started. First of all, I can see that ACB angle is equal to angle DCB. Well, this is actually given, okay, according to the dots on the diagram. And second of all, we have AC equal to DC. This is also given, okay, according to this these dashes over here on the diagram. Now, lastly, we have BC equals to BC. Okay, these are not really given, but these are we're actually talking about a line that is shared towards both triangles over here. So for sure, these are equal over here. It's quite intuitive. Now, because of all these three pieces of information over here, you can finally say that ABC is actually congruent to triangle DBC. Okay, and the reason behind that, you also need to mention about a reason at the end. That the reason behind that is SAS. Okay, because we have one line over here being the same. Okay, and then there's a shared line over here, and then we have an angle, same angle that is folded in between the two lines. Okay, so that's SAS. And also pay attention to your order when it comes to writing the triangles. Okay, so for example, in this case, A is actually corresponding to D. You actually do have to make sure that they are corresponded. Okay, and then your B over here is corresponding to B. Okay, that's for both triangles. We're talking about the same corresponding tip over here, or vertex. The last one, we're talking about C and C over here. Okay, so we actually need to make sure that all three letters are corresponding to each other. Okay, so that's the end of the proof. You can put a little square over here to kind of tell people that this is the end of my proof over here. Okay, take a look, see if you're okay. Okay, second question. We're going to pretty much follow exactly the same structure over here. First of all, we have BC equal to CD. Okay, so this is given. And then the second one, we have AC equals to AD. This is also given. Okay, last thing, we have AC equals to AC. This side is shared towards both triangles, so we write a share. Okay, therefore, with all these three pieces of information, we can conclude that triangle ABC is congruent to triangle ADC. Okay, and the reason behind that is SSS over here. We have three sides being the same correspondingly. Okay, so every time you will see that we have a statement over here, a statement over here, and a statement over here. So these are all the statements. You'll see me using a square bracket over here, but the textbook uses a curly bracket. It's really up to you. Okay, as long as you mention about the reason over here behind your statement, behind each of your statements. Okay, that's exactly the structure we want it to be. Okay, including your homework, including the test that you write. Okay, and finally, we also have this statement over here. This is also a statement, and then we also have a reason. And it's really up to you whether you want to put a little box over here or not. But it just, it just looks cool. Now, moving on to the next question over here. Guys, now we are actually looking at the problem in a little bit different way, because we are actually not proving the congruence of triangle. We are actually using the fact that triangles are congruent, and then we're going to prove something that we don't know. For example, we actually don't know in this case. Nobody actually tells us that AB is parallel to DE. Okay, but we're going to use some information that we know to first of all prove that we have two congruent triangles. Well, it looks like it, but we're going to prove it. And then we're going to use the fact that the triangles are congruent, and then we're going to conclude that the two lines are parallel. Okay, so let's start. First of all, we have AC equals to CE. Right, this is given. Second of all, we have BC equals to CD. This is also given. Last thing, we have angles DCE equals to angle BCA, actually. Right? We're actually talking about opposite angles over here. Opposite. Okay, so we're talking about these two angles that are opposite, vertically opposite. Okay, and then first of all, you will claim that the triangle ABC is congruent to triangle EDC. Okay, watch out the order. The reason behind it is SAS. And now just because we have congruence, we can actually conclude something about a triangle. We can actually conclude that, first of all, we need to know what we need to prove over here. We want to prove that these two lines are parallel. We don't actually need to prove that they're the same. We just need to prove that they are parallel. But how do we know that they're parallel? Well, if you look at this little dashed line over here, if we could have these two angles being the same, we have the zigzag situation over here, then that actually means we have two parallel lines over here. And the fact is, it turns out that we could actually claim that ABC, angle ABC, is actually equal to angle EDC because of the congruence. So because of the congruence, we can actually see that these two angles are the same, even though nobody actually told me that these two are the same. But just because I know that they're congruent, I can claim that these two angles are the same. Okay? And just because these two angles are the same, we are actually done. We will finally be able to say that AB is parallel to DE. And the reason behind that is because we have alternate angles being the same. And that's the end of the story. Now, the last example of the day, we have a few pieces of information. First of all, we know that triangle ABC is isosceles, so we know that AC is equal to BC. Guys, it's always a good idea to mark it down on the diagram over here, so let's do that. Now, second of all, you have BC and AC that are produced to E and D over here. What does that mean? That basically means we're extending the lines over here to reach the point E and the point D. In this case, they actually tell you that CE is equal to CD. Okay, that sounds good. Okay, but that also means that we have straight lines. We actually have straight lines, BE and AD. Okay, and just because we have straight line over here, we can actually continue this question, because that first of all means we have these two angles being opposite angles, vertically opposite angles. So there you go, we have three pieces of information, so let's write them down. First of all, we have EC equals to DC. Okay, this is given. Second of all, we have the lines being the same. We have AC equals to BC. This is also given. Now lastly, we have angle ECA equals to angle DCB. But this is vertically opposite. Okay. Now finally, with all three pieces of information, we can claim that triangle ECA equals to triangle DCB. Okay, and the reason behind that is SAS. Now we're not done yet, because we're proving AE equals to BD over here. So you could actually just claim that because of the congruence, we can also have AE equals to BD. Okay, and the reason behind that is because we have congruence. Right, just because we have the congruence of the triangle over here, we can just because we know that the two triangles over here, okay, they are congruent. That means these two correspondent sides are exactly the same. Okay, so that's the end of the proof. So that's it for today, guys. Here is your homework. Stay healthy and stay safe. I'll see you tomorrow. Peace.